In this video I shall explain iteration method, which is also called fixed point iteration method or method of successive approximations. With the help of this method we can solve an algebraic or transcendental equation in the form f of x equal to 0 for the real variable x. The working rule that we can adopt to apply this method is as follows. In the first step we identify an interval a comma b in which a root of the equation f of x equal to 0 lies by knowing that f of a and f of b have opposite signs. As fx is a transcendental or algebraic function, it will be a continuous function, and whenever fa and fb have opposite signs, with the help of intermediate value theorem we can confirm that a root of the equation fx equal to 0 lies in open interval a comma b, and let that root be alpha say. By identifying this interval a comma b, we go for selecting a point of this interval which is nearer to the actual root alpha as the initial approximation of alpha. We need to select this initial approximation denoted by x0 as a value which is nearer to alpha. If at all we know that the actual root alpha is nearer to the left end of the interval a comma b say, then x0 is to be selected as a value nearer to a, the left end of the interval. If at all we know that the root is alpha is nearer to the right end of the interval, then x0 is to be selected as a value nearer to the right end of the interval. Usually the midpoint of the interval serves the purpose. So x0 is to be selected as a value which is nearer to alpha as the initial approximation of alpha. And on selecting x0 value, we go for expressing the given equation fx equal to 0 in the form x is equal to phi of x, where the function phi of x has to satisfy the convergence condition, which is mod of phi dash of x at x is equal to x0 less than 1, means the absolute value of the first derivative of phi of x at the initial approximation should give a value which is less than 1. If this condition is fulfilled, if this convergence condition is fulfilled by the function phi of x, then this particular relation x is equal to phi of x can be used as an iterative scheme to get the successive approximations of the root alpha, from which we can have x1 is equal to phi of x0 as the first approximation of alpha, and x2 is equal to phi of x2 as the second approximation of alpha, and so on. Xn is equal to phi of xn minus 1 as the nth approximation of alpha. We calculate these successive approximations of the root alpha, and we continue the process till two successive approximations coincide in the required number of decimal places. Usually by applying this method we calculate roots correct to 4 decimal places. Now I shall explain a solved problem on iteration method. Here is the problem. Find the real root of f of x is equal to x square minus 3x plus 1 is equal to 0 corrected to 3 decimal places, starting with x is equal to 1 by iteration method. Starting with x is equal to 1 means 1 is to be considered as the initial approximation, and hence here x0 value will be equal to 1. And then we express the given equation fx is equal to 0 in the form x is equal to phi of x, so that phi of x satisfies the convergence condition. Now I shall explain different possibilities of expressing the given equation fx equal to 0 in the form x is equal to phi of x, and the selection of phi of x satisfying the convergence condition. Here the given equation is x square minus 3x plus 1 equal to 0. In the case of the first possibility, we combined the two terms x square and minus 3x to get them as x into x minus 3, and which will be equal to minus 1, and from which x is equal to minus 1 by x minus 3. And now it takes the form x is equal to phi of x, where phi of x is minus 1 by x minus 3. And for this phi of x the convergence condition is to be verified, and for that you can take the help of the calculator. To use the calculator and to get the modulus in the calculator, you need to operate shift and then left parenthesis key so that modulus can be obtained in the calculator. And then to get the first derivative d by dx in the calculator, operate shift and operate the integral key so that the first derivative d by dx will be appeared in the calculator. And then the function to be used here is minus 1 by x minus 3 in the case of the first possibility. And the x value is to be given as x0 value, which is 1 here, and on pressing equal to key, operate equal to so that you will get its value as 0.25. so it is a value less than 1, and hence this relation x is equal to phi of x can be used to apply iteration method. And in the case of the next possibility, we kept x square on one side and wrote other terms on the other side, so that x will be equal to 3x minus 1 whole power 1 by 2. And for this function phi of x, once again you can go for using the calculator and you can get its value, convergence condition value, as 1.06, which is not a value less than 1, and hence this relation x is equal to phi of x cannot be used to apply iteration method. And in the case of the next possibility, we kept 3x on one side and wrote the other terms on the other side, and hence x will be equal to x square plus 1 by 3. Once again we got it in the form x is equal to phi of x, and for this phi of x the convergence condition value is 0.67, which is once again a value less than 1, and hence this relation x is equal to x square plus 1 by 3 can be used for applying iteration method. In the case of the next possibility, we multiplied on both the sides, the equation is multiplied on both the sides with x, so that we can have the terms x cube minus 3x square plus x equal to 0, from which x is equal to, one way of getting x is equal to minus x cube minus plus 3x square, and here phi of x is minus x cube plus 3x square, and for this phi of x the convergence condition value will be equal to 3, and which is not a value less than 1, and hence this relation x is equal to phi of x cannot be used to apply iteration method. So of these possibilities considered here, so many other possibilities arise. We considered only these possibilities. Of these possibilities considered, the first and the third one are useful in applying to apply iteration method. Even of these two possibilities, the first one is the preferable one. The reason is that the convergence condition value is 0.25 in the case of the first one, and in the case of the third one it is 0.67. As the value 0.25 is a value closer to 0, we prefer this particular form, first form, to apply iteration method. The convergence condition value should be a value less than 1, and we prefer such function phi of x for which the convergence condition value provides a value which is closer to 0. So of these two possibilities, the first and third possibilities, the first one is the preferable one to apply convergence iteration method. So here we considered the form, first form, x is equal to minus 1 by x minus 3, which is obtained from the given equation itself and which satisfies the convergence condition. And for this phi of x, this relation x is equal to phi of x, we go for the obtaining successive values of x. And this relation x is equal to phi of x itself serves the iterative scheme. And we go for the tabular form with the first column consisting of the iteration number n, and then the second column consisting of xn minus 1 values, and the third column consisting of xn values. Xn is nothing but phi of xn minus 1. So in the case of the first iteration, n value is equal to 1, and hence xn minus 1 will be x0, and its value is equal to 1, and then xn will be equal to x1. To get x1, phi of x0 is to be calculated. To get phi of x0, once again you go for the calculator and get phi of x in the calculator, which is minus 1 by x minus 3, and then operate calculate key and provide x value as 1, as x0 value is to be given here, and then press equal to key to get its equivalent, which is 0.5. As we are asked to calculate the root corrected to 3 decimal places, so we note down the values corrected to 4 decimal places by fixing the calculator for those 4 decimal places. Okay, and then for the next iteration, the iteration number will be equal to 2, and then xn minus 1 will be x1, which is 0.5, and then xn will be x2, which is equal to phi of x1. So once again use the calculator where phi of x is available, and then press calculate key, provide the x value as 0.5, and then the calculator gives the value as 0.4. Like that you proceed to calculate the successive approximations of the root, and you terminate the process when two successive approximations coincide in the first 3 decimal places. In the 4th and 5th iterations, the successive approximations are coinciding in the first 3 decimal places, and hence we can terminate the process, and we can conclude the problem by noting down that a root of the given equation corrected to 3 decimal places is 0.382, neglecting the 4th decimal place. So the answer is 0.382. That is all about the way of doing a problem on iteration method. Thank you.